All right, so on homework for problem set 3. So there's the work for those first couple of answers. How'd you guys do? Pretty good? Okay. Either game show or comedy, that one was 0.35, and then your complement would have been 0.77. Then followed by your blood type question. And I don't know whether these are true or not. So probability of not having that would be 0.04. Mutually exclusive means the same thing as disjoint. So you could say that too. Actually, no, I don't even think you needed to state that, but those have no outcomes in common. So no outcomes in common. And the next answer was 1 minus that, which is 0.30 or 30%. How's page 1? Perfect. Yes, probability always is. Yep, absolutely. If they were percentages, use 100%, but if it's a decimal, just use 1.0. Next. So you're going to sketch some of this out, and you're basically going to use your union rule to get whatever value you happen to be missing. So that's the easiest way to go about those. And then probability of being defective. So again, you're looking for the complements there. So 1 minus 0.01. And then raise to the 12th, because you got 12 of those, unless you want to write it out 12 times, which I would kind of encourage you to avoid. And then quality control inspection, you're going to multiply those events. And again, when you see independent, think multiply. Because again, those have no outcomes in common. And then lastly, number 8 should be 21 students who play basketball. All right, how did you guys do with the beginning of those probability ones? Because you got to be careful the middle. Yep. Got to be very, very careful the middle. Okay. If you think of something, let me know. All right, so then let's pick up where we left off, guys, and that would be in your lesson 4. Again, I am going to skip around a little bit because I want to give you what's important. And we were in, let's see. Yeah, find this question if you don't mind. So this is the back of your lesson 4 notes. And it's talking about an online bookstore. And again, I'm going to jump around through your review a little bit. We'll kind of do, we'll do some problems here and there. So you are given an online bookstore offers a large selection of books. Some of the books are works of fiction and some are not. And some are ebooks, some are not. So let us choose our books that are fiction and A be the books that are ebooks. So we need to draw a Venn diagram. All right, we got a lot of space over here. You can make this as big as you would like. But we need a rectangle. And then you're going to put your circles inside of it. And they're going to obviously overlap. So make sure you account for that. And over here too. Okay. And I have one of these that is fiction. And I have one of these that is ebooks. So a little bit of labeling just for our purposes here. Now, what you want to do is start with the information that is the most specific. So it tells us 62% are fiction. That means the full circle. You can't really label anything yet. I also know that 47% are ebooks. I can't label that really yet either. But I know that 14% are ebooks that are not fiction. So can I put that somewhere? Yeah, so I'm going to put that right here. And the 14%, I'll just go 14. So I'll just leave the decimal off. So ebooks that are not fiction. All right, so now I know ebooks. That full circle needs to add the 47%, and I already have 14 of it. So what's left over for the middle? Yep, very good. So this is 33. And And then I'm going to go to the other side and I'm going to deduct that as well. So then the next one I have here is, what did we have? 62% minus 33% is equal to, yep, thank you guys, 29%. And, you know, while you're at it, it just usually makes sense to finish this. So what is 100% minus 29, 33, and 14? Thank you. So that goes here. Again, just in case you need it. You probably do. So using your Venn diagram, find the probability that we want to be a work of fiction and an ebook. So I want the probability that I am going to be fiction and an ebook. And I'll warn you too, sometimes when you do these notations, like F raised to the C, some of them might look a little, you know, alarming, but I do want you to write the notations, okay? I know you're not like trying to stare at me or anything. Or when you see the F and then the union and then the C, but keep using your notation. So fiction and ebook. So what number is going in here? Yep. So we have 33 out of the 100%. So we're going to go just 0.33. Or again, if you want to leave it as a percentage, that's fine too. All right, next we want a work of fiction or an ebook. So this one is a, instead of an intersection, this one is the, you guys remember? Union. And again, I'm aware of how these things look. They just always look strange to write. But it's good notation to get comfortable with. So to do my union here, I'm going to go all the way across my picture. So I'm going to add the 29 and the 33 and the 14 over my total, 100%. And what is 29, 33, and 14 equal to? Is it 76? Mm-hmm. Yeah, so 0.76. And then next, we want this to be neither a work of fiction nor an ebook. So these are the complements. So the probability that this is not fiction and this is not an ebook. So that number was 24 out of 100%. Again, equal to 0.24. Right, so 0.24 there. So continuing that question further, what we're going to do is make one more what is called the hypothetical 1000 table to show the information just a little bit different. So we can take it and kind of break it like this as well. So it's just a different visual interpretation. So when you create a hypothetical 1000 table, the total is 1000. And again, why do we do that? So that we don't have to work with little insignificant decimals. Meant to make it a little bit easier. I am given here that 62% of books are works of fiction. So that goes here, and that is going to be 620. And then what number do you think I should find right after that? How about this one, right? This would be 3. Good. Next, I have 47% available as ebooks. So this would be 470, which gives me the next value beneath that would be, yeah, good, 530. So you just build it as you go. Next, what do we have here? We have 14% that are ebooks, but not fiction. So this is 140, which means to the left of this is going to be, yeah, very good, 330, which means beneath that is going to be, thank you, and the last entry would be, thank you, you're so fast, 240. Appreciate that. Okay, so that's your hypothetical 1000. We took your Venn diagram, translated your information like this. All right, and then the last thing you're going to do with that problem is complete each of the following by finding the probabilities. So basically, we're going to do 330 divided by 1,000. And what's that equal to? Yes, this would be 0.33. This guy would be, I think it was like 0.14. And then 0.47. And then probability, yes, is always based out of 100%, 1.0, meaning this would be 0.53. The 620 would be 0.62 and 0.38 and 0.29 and 0.24. And how do these probabilities relate? They are the same. Okay, just a different way to express your data. So you've seen Venn diagrams, you've seen two-way tables, and then you've seen the ones that take the two-way table and break it into a probability expression instead. All right, so all the way over next to lesson 5 that says probability review. Over to the question with the band. Band and sports. I believe we have to draw another Venn diagram here. So again, I hope you like to draw. Guess they're not at least difficult to draw. So next, at a high school, there are 833 students and 463 participate in organized sports, 52 in band and 21 in both. What information that I just read is the most specific? What number? Yep. Where's this going? Yep, right in the middle. So that's step 1. Okay, so let's draw this Venn diagram. I'm gonna try doing it like this instead. I don't know what makes it look the best. And then rectangle. I guess I could get the compasses out, right? Wouldn't that be fun? Just kidding. I'm not sure if you guys remember, missed doing that last year. You did a lot of it, right? Yeah. So we have 833 all together, and we were going to start right with 21. And we were looking at sports, and we were looking at bands. Okay, so I'm going to work with this 52. Full circle's 52. I already have 21, so that leaves me with, yep, very good, 31 here. Next number, can someone please do, what is 463 minus 21? 422. Thank you. And then we might as well find the complement while we're at it. So we need to do 833 minus 442 minus 21 minus 31. Thank you. 339. I think we got everything now. So we would like to first find, and again, we'll practice notation again, find the probability that a student selected at random participates in neither sports nor band. So this is your complement. So we want the probability of no sports and no band. And how many students was that? Good, 339, because we already found that. And this is out of 833. And decimal would be fine if someone has that. Thank you, 0.407. Perfect. All right, so next, I would like the probability that the student participates in sports or band. So I want the probability, and I'm going to write this as my union. Sports or band. So this is equal to, I'm going to go all the way across my Venn diagram because I've already gotten rid of the extra. So I do 442 plus the 21 plus the 31, and it would be nice if you show this. We do like to see that work. And then divided by 833. Okay, as a decimal, I didn't write that one, I'm sorry. 0.593, thank you, 593. Perfect. All right, next. If a student participates in band, okay, so that's out of the 31. What is the probability that the student participates in the sports? So this is going to be the probability of sports given band. So I have my sports given band is 21 over 31. It is not. You have to be careful with this one. Yep, this one's conditional. So what is 21 over 31 equal to? Someone have that? Yeah. And this is where probability gets tough and you start to accidentally like second guess yourself. Wait, what was it? 6, 7, 7, 7. Yep. Okay, so I want the probability that a randomly selected student participates in sports. Now what number am I going to use? Let's see. Yes. The probability of sports. Yep, that grand total was, yes, the 463. I'm going to go 463 divided by 833. Because this is just a general probability, it's not conditional. So what do we have here? 0.556. Perfect. And now the next question asks you, are the events independent? So if you compare C and D, because this is one test that we did for independence when we had those two-way tables, or, you know, and this is since you have your given information right now. Were those equal? No, so you're just going to say no. So no, again, not equal. For this to be the case, the probability of S must be equal to the probability of S given B. Yep, so that one is a not. So now we're going to take it to a two-way table instead. I'm just going to do some of these. So you are given a large marching band, and engineering majors were heard bragging that the students majoring in engineering are more likely to be involved in marching band. All right, so M is marching band, and E is going to be engineering. So at first it says describe the event represented by the complement of M and find its probability. So describe, that means words. So what is the complement of M? Correct. Yep, people not in marching band. And now I'm going to find it. So probability of not being in marching band. How many of those guys do we have? Very good. 645 out of the total 805. Someone have that number? 0.801. Thank you. So pretty high probability there. Describe the events. M and E. So M intersect E. So this means the probability that the student is in marching band and engineering. I'm going to abbreviate. So marching band and engineering. So I'm going to do the probability, and the intersect symbol is this one. Engineering was the letter E. Okay, so I'm going to go up to the box that says marching band and engineering. It's just the 40, right? Yep, just that small number. So 40 out of 805 equal to 0.049. Okay, thank you. Works for me. All right, now this next one. This is the first time you've seen this. So we did the union rule yesterday. This is going to be a union rule from a two-way table. So what you have to think about is the overlap that we haven't already accounted for because we don't have a Venn diagram here. So to do the union, I'm going to write the rule out. So the probability of M or E is equal to the probability of M plus the probability of E minus the overlap that we have not already accounted for. Because again, you don't have a Venn diagram this time. So that's why you have to use that rule. Because otherwise you're double counting people. We don't want to do that. So probability of marching band. How many marching band people do we got?
160.
Yep, very good. So 160. Plus, how many engineerings do we have? 175, yes. And now, how many have we already double counted that we need to get rid of? 40, excellent. And this is out of my total, which was 805, yeah. And then you're gonna grab this probability. But again, when you have a two-way table, you have to account for that overlap there. So what is this one equal to? I didn't write that one down either, I apologize.
0.366.
0.36. Thank you. Good. How are those so far? Good? Okay. Again, the two-way table works differently than the Venn diagram does. So that's why you have to think about the people you've already counted twice. So flip over and you can cross off all those parts because we are not flipping back and forth. That gets annoying. So let's look at the brake fluid and we'll look at Josie. I know it gets hard on the tables and you keep flipping constantly. All right, so number 3. When a car is brought to a repair shop for service, the probability it needs transmission fluid replaced is 0.38. So I'm going to start writing that out, just because when you've got a big paragraph, it gets wordy. So let's do probability of, I don't know, pick a letter. T, that works. Whatever you want to use. So this would be what, 0.38. Next valuable information. Probability you're going to need brake pads is 0.28. I'm going to go B. And that is equal to 0.28. Next, the probability that you are going to need transmission fluid and brake pads is 0.16. So probability of transmission, and so this is intersect, E is equal to 0.16. And let's see, events T and B, got that. What is the probability that the randomly selected car needs the fluid? So T or the brake pads. So I'm going to label this one as just plain, I don't know, X. So what I hope jumps out at you, especially when you label the information on the side, is this is the union rule from yesterday. Okay? So I'm going to start this and write the formula. So the probability of transmission or brakes is equal to the probability of transmission plus the probability of brakes minus the probability of transmission and brakes, the overlap. So again, from the Venn diagram, you already account for that. But when you don't have the Venn diagram, and if you don't feel like drawing one, which, I mean, you can make one for the situation instead if you prefer, but it's kind of like why. So this is X is equal to, I'm going to sub in 0.38 plus 0.28 minus 0.16. And does anyone have that yet by chance? 0.38, 0.28 minus 0.16. 0.5, thank you. The probability of T or B equal to 0.5. Awesome. All right, how are we feeling with the formula? Getting good? Mhm.
So since it's the union,
Mhm.
why do you subtract the?
You've already accounted for them, just like in the Venn diagram. Mhm. Just think of this as the overlapping section from the Venn diagram. Yep, that's the easiest way to do it. But again, if you don't like the formula and you want to draw out the Venn diagram instead and add across, you could do that too. Either way would be totally okay. So Josie's going to take exams in math and Spanish. She estimates the probability she passes math is 0.9. I'm going to write that. The probability of math equals 0.9. And the probability she passes Spanish is 0.8. She is willing to assume that the results of the two exams are independent of each other. Okay? Nothing to do with each other. Assuming her assumption of independence, calculate the probability that she passes both. So the probability of her passing math and Spanish is equal to the probability of passing math times the probability of passing Spanish. So what do we got here? So we're going to go 0.9 times 0.8. But you guys can even do this in your head. Yes, good, 0.72. Okay. So now, Lindsay, you're going to find the probability that she passes at least one of the exams. So we're going to do probability of math plus probability of Spanish minus the both. So we're going to go probability of Spanish or math or vice versa would be equal to the probability of the Spanish plus the probability of the math minus the both. When in doubt, all these union rules, they tend to come in pretty handy. So Spanish plus math minus the 0.72 we just found. So I am going to go 0.9, oh, sorry, vice versa, 0.8 plus 0.9 minus 0.72. We have an answer for that?
0.98.
Thank you, 0.98. Pretty high percentage. How's that one, okay? All right, on to the next page. Pick and choose here. And we'll do another one of those. And again, when you see all this text, do what I've been doing and translate it on the side so that you don't have to work with all the wordiness. So we have, when a call is received in an airline call center, the probability it comes from abroad is 0.32. So I'm going to say probability of abroad 0.32. Next, the probability that it's going to be a changing reservation. Oh, change an existing reservation. I'll use R. And that is equal to 0.38. Suppose that the probability that a call is from both abroad and to make a change. So this is an and situation again. This is intersect. So A and R. So that was 0.15. Thank you. And then we want to find the probability of the or. So we want the union. Probability of A or R equals X. So you're going to write your formula out again. So we're going to have here the probability of A or R is equal to the probability of A plus the probability of R minus the overlap. So probability of A and R. And we should have always at least 3 out of 4 numbers. This one we don't know. Probability of A is 0.32. Probability of R is 0.38 minus 0.15.
0.55.
0.55? Thank you. This is equal to 0.55. Awesome. All right, so now B, extending this. So suppose that you are not given information in part A, but you are told that the events are independent. Independent means I do what with the probabilities? Multiply them, good. So I'm going to start with that to find the probability of A and R occurring together. So A and R must now be equal to the probability of A times the probability of R. And then we're going to use this number instead. So this is equal to 0.32 times 0.38. Does anyone have that by chance? Thank you, 0.122. So this is probability of A and R. So now you're going to use that value to determine the probability that the call is from abroad or to make a change. So all I do is I take this formula and I sub in the 0.12 instead. So now I go probability of A or R equal to probability of A plus probability of R minus the probability of A and R that I just found. So this is now going to be 0.32 plus 0.38 minus 0.12 or 0.122. You guys pick. All right, what do we have?
0.578.
0.578. Thank you. Perfect. So do we see how that changes when they talk about the independence? Okay. Couple more. Yes, I want to do this next one with the genders. So you have a partial two-way table here to kind of get set up. A survey was given of students' genders and their preference for basketball, soccer, or track. 5 girls are going to prefer track. You need to put that in. And 4 boys preferred track. Okay, so I can get this number. Oh, I can get this number. There we go. Keep reading. What else do we know? 15 girls preferred soccer. I think that's there. 25 students preferred soccer. So males are going to be, yep. We surveyed 50 students altogether, 30 of which are girls. All right, so letter A asks, so what is the probability that a student preferred basketball given the fact that she was a girl? So probability she preferred basketball. Given the fact that she is female. All right, what do we got here? 10 over, yep, very good. 10 over 30. So that is equal to 0.3. All right, so next, so letter B. Are being female and preferring soccer independent events? So this is back to your two-way table. So I am going to first start with the condition of being female. So I'm going to go up and I'm going to circle these. So if I go up and circle, how many females do I have? 30 out of how many total people? Good, circle, circle. Good to follow the same pattern. So this is equal to 30 over 50, equivalent to 0.6. Now I'm going to attach the conditional. So now I want these people to be female, given that they participate in soccer. So I'm going to go to my table and circle again. So do you see how these are right on top of each other? So the same pattern is going to occur. So go to the soccer column, and what numbers line up with those? Yeah, and this again, I use as a nice little trick to always kind of help. Always going to follow the same pattern. 15 over 25. Does anyone have that decimal by chance? Okay, perfect. So are these independent events? Yes, they are. These are equal probabilities, thus independent events. Equal probabilities, thus independent. And they have to be perfect, okay? So no rounding. So thus independent. All right, so number 7. So multiple choice.
I have a question about the last one. So why wouldn't we have done 25? Like just to, like everybody will fail.
Oh, because you need, like for the second one?
No, like why did we do females who like soccer versus like just people in general who like soccer?
Oh,
Like
'cause it-
25 over 50.
Because it told you female.
Oh, okay. I wasn't
Yep,
sure if it
That's
was
okay.
female, like, is it, and then people who put them in soccer.
So whenever you do a test for independence, you take the first condition. And then you read and you take that condition given the new condition. So it always gets actually written like that. Yep. So whatever you start with here repeats it. So here's actually another one of those. But don't feel bad. The independence testing is usually the hardest part about this chapter. So we are given that Sean's team has baseball tomorrow. He pitches 50% of the games. Again, I'm going to encourage you to write that out. Probability that he pitches equals 0.5. Then you can look at the numbers here. Next, there is a 40% chance of rain. So probability of rain is equal to 0.40. Next, if the probability that it rains, given that he pitches. So probability that it rains, given he pitches, is 0.40. Then what can we conclude about these events? Do you see how your notation's written identical to the female and sports one? Yeah, so what can we say about those two? Yes, and again, that's how you set those up. So it always takes the new condition provided the one you're attaching. So these are independent events. All right, so I think I will stop there because that's probably enough of those anyways. Give you your assignments for the rest of the week and give you a couple minutes to kind of start. So for you guys, all you need to do is you've got a Delta Math review assignment and a quiz. Be careful of your rounding. Trying to think what other pitfalls you may see there. You'd probably be okay, but the review ones are going to be identical to the quiz ones. Take your time because those questions are not going to give you 2 attempts. And then you guys are not here tomorrow, so you are here next Monday. Bring your other packet with you, please, because we are moving on to the computational based aspects, so kind of like your z-scores and your statistics, standard deviations. And then we are nearing the end. There are 20 lessons that we need to get through, and then we will do some review. You do not have anything in the packet for this week.